hydraulic systems. Specifically, I'm a 20 years hydraulic guy. I've had the pleasure, Roger, double-edged sword, the pleasure of working with one industries for the last 20 years, or 16 years, 15 years, 16 years. The double-edged part of that sword is I've had the pleasure of working with one industries for 16 years. You know, listen to Bernie. Bernie's got a ton of passion. I hope I can show half the passion in my presentation that he showed in his. For me, it gets a lot simpler. For me, because I'm in sales, I'm in design, it comes to dollars and cents. Inefficiencies, loss of energy, wear, cost dollars. That's where I come from. If I can go to an Elements or a Step or Dale Constantine somewhere out there and save them dollars and prove to them that the ROI that they're investing in the product is worth something, then I've accomplished my job. Now, when you talk about specifics about the hydraulic industry, where does contamination come from? Well, you've got the initial problem. Number one, the person you trusted to manufacture your piece of equipment did not do it properly or did not take the proper amount of care. The system had a dirty tank. They didn't pig the lines. They were welding and grinding when the tanks were open. They didn't put in proper filtration. So that's the number one place where you ingress or create contamination. This represents a standard hydraulic system: valves, motors, pumps, cylinders. You know, you can move along. You go to the breather. Well, where does contamination come from a breather? It's in the air. Hydraulic tanks, the level of the hydraulic tank move up and down. That's why you need a breather, or else you'd have a vacuum in your tank. You're ingressing all that contamination through the air. Metal particulate, silica, it's all getting into your system. Moving parts, cylinders, valves, motors. Anybody here have any hydraulic experience? Jamie, thank you. Anybody? Anybody else? Ferris, thank you. Bueller, there we go, a couple more. The rotating shaft on a hydraulic motor takes external contamination and brings it past the shaft seal into the motor. It creates its own wear. The shaft seal on a cylinder. Every time that cylinder extends and retracts, it's taking a certain part of that wear and bringing it into your fluid. The original oil coming out of the barrel. Anybody here work with oil distributors or manufacturers? There you go. Have you ever asked one of your oil distributors to tell you an ISO cleanliness level, guaranteed ISO cleanliness level that they're distributing? And their answer is, what's that?
Give it to me.
Yeah. And their answer is, yeah, sorry.
No, I work with Royal Purple. They actually use one eye on there.
Royal Purple would be one of the few. I've worked with Petro-Canada. I've worked with ConocoPhillips. I've worked with Esso lubricants, mobile lubricants. And I said, guys, tell me, when I buy new oil, what is the ISO cleanliness level? When I'm taking that and putting it in my piece of equipment, what are you giving me? They get real silent real quick. Okay? They will not give you a document that guarantees the product may be out of a tote or a barrel, barrels being the worst, by the way. What is in that oil? They'll tell you that it's a 3-part oil with this add pack and it's great and it's going to give you this type of life. And okay, but what else are you giving me? What else is in there that I don't know about? They get really bashful real quick. So be aware of that. So now, we have a thing called the hydraulic cycle. The dirty oil is in the tank with all the particulate and sediment. It goes through my pump, it goes through my valves, it goes through the motors. What is happening when that happens? Wear, exactly. You've created a wear cycle. So one particle of wear, a piece of iron, a piece of whatever, begets 2. So now I've got a total of 3. And it goes back, hopefully through a filter, traditional filter, It may or may not get caught. If it doesn't, what does it do? It goes back into my tank, the 3 particles, and those 3 particles beget 9 particles. So you've created a wear cycle. What does a wear cycle cost? What eventually is that going to cost you? What's that? I'll make it even simpler than that. Here, we'll do it this way. Dollars. Every ounce of wear costs you dollars. Every time you get a wear particle, that's a $15,000 motor. Instead of getting 5 years life out of it, or 10 years life out of it, I've gotten 2 years life out of it. What does that cost me? Dollars, because I didn't take care of this problem here, that actually might have started here. It cost me dollars. It cost me real money. So I had the pleasure of sitting through the end of Bernie's discussion, and somebody said, if I can't work with the managers, who can I work with to get my product in there? Who's going to listen to me? In my experience, a lot of times, it's the guy controlling the dollars. Okay? When you can prove to them that the traditional way of doing business is costing them dollars, sometimes you get somebody in the accounting department, somebody who's making decisions, financial decisions, to look at those dollars that you're spending. Why are we spending $5 million a year on maintenance? What is that costing me? What type of ROI can you give me? What type of investment can we produce together? That's the way I look at it. So you look at the types of contamination, as we spoke about earlier. You've got your traditional wear particles, water ingression, like we said, through the breathers and the shaft seals and stuff like that, and heat. Heat is a byproduct of wear. Okay? All those things lead up to, okay, wear is 70-90% of failures, 10 to 30% misuse. I didn't use the product properly, I misapplied it, but 70-90% of your failures is wear. Okay? In the hydraulics industry, that correlates into billions of dollars a year. Parker Hannifin, Bosch Rexroth, the Eaton Corporation, they love this. They want to sell you all kinds of spare parts, repair parts. That's their job. You know, if you looked at the breakdown of these corporations and where they make their money, there's a significant cost or burden in failure, spare parts and broken parts. I'm going to use, because of my friend Jamie back there, I'm going to use Ford for example, because I'm a big Ford fan. You go to the Ford lot, you can buy a new Ford truck. What do they cost, Jamie? $1.25? Something like that. Try to buy that truck in parts. What is it going to cost you? Anybody ever thought about that? Go and buy that complete truck. The steering wheel, the wheels, the engine, the rotors. Buy that truck in parts. That truck is going to be 5 to 7 times more expensive than when you bought it off the lot as a completed truck. Equipment manufacturers, specifically in my application, hydraulic equipment manufacturers, want to sell you parts. They make more money. That is part of what they do. In the hydraulics world, we talk about contamination in micron sizes. Who out here understands what a micron is? Okay, a couple of people have been exposed to this. 40 micron is somewhere between 30 and 40 micron, for those of us not wearing glasses, is the visible limit. It's what you can see, okay? You get down to red blood cells, you're below 10 micron. Talcum powder, white blood cells, you can see this, okay? Pollen, fog, just as examples. So when we have something to reference to as we go on with this conversation. In hydraulic systems, we have components, piston pumps, gear pumps, vane pumps, servo valves, okay? Hydrostatic bearings, gears, okay? A piston pump, which a lot of us would be aware of, has a tolerance of between 5 and 40 micron, okay? In this day and age, they're usually 5 micron or tolerance in the super high pressure pumps, okay? That's the distance between the piston bore and the wall, okay? Valve plates, which is the rotating barrel, and the plate, the sacrificial plate that wears up against it, 0.5 micron to 5 micron clearances, okay? Gear pumps are a little more forgiving. Vane pumps, again, a little more forgiving. But then you get up in the servo valves, okay? Anybody here been to Vegas? Las Vegas had the pleasure of seeing the Cirque du Soleil show Ka, okay? I had the pleasure of seeing it recently. That whole thing is a dynamic stage that goes up in the world, and it rotates, and it flips the characters around, and it's quite entertaining. I got to see backstage. It all runs off of servo valves, between 1 and 4 micron clearances, okay? Hydrostatic bearings, the rotating bearings inside a pump or a motor, 1 to 25 micron, okay? Keep those numbers in mind. We get into ISO cleanliness, okay? This all actually leads up to something. In an ISO cleanliness world, with an ISO cleanliness of 18, 16, 13, which is your typical ISO cleanliness in a hydraulic system, Bosch, Rexroth, Denison Hydraulics, Parker, they recommend that you have to keep your system at a minimum of an 18, 16, 13 ISO cleanliness. We'll get into what that means in a minute. In a 30-gallon a minute hydraulic system, in a given year, would mean with an 18, 16, 13 cleanliness, you've put 20 pounds, 20 pounds of contamination cycled through your system continuously in a given 12 months. If you allowed your system cleanliness to go to a 22, 21, 18, and if you look at it, the relationship, there's not a big jump in numbers there, okay? 630 pounds of wear contamination would go through your system, okay? Now, these slides I stole from somebody else. I didn't create these. I didn't do the math on how to do it. These are actually Caterpillar's numbers. When Caterpillar tries to sell their filtration, this is the presentation they use. So if we're going from an 18, 16, 13 to a 22, 21, 18, I've got a 610-pound difference. Who thinks that's a bad idea? Show of hands. Anybody? Bad idea? Bad idea. Trick question. Who thinks 20 pounds is a good idea? Well, in comparison to 630 pounds, yeah, it's a good idea. But 20 pounds is not a good idea. Even though you're reaching the manufacturer's suggested cleanliness level, it's still not a good idea. We're talking about ISO cleanliness levels here. When you talk about ISO cleanliness, if you've got a 18, means that there is a particular count of greater than 1,300, but less than 2,500 parts per milliliter. Okay? So when you go to 18, 16, 13, this is what we're talking about, parts per milliliter. When you go to, which doesn't tell you a heck of a lot to begin with, the first number being 18 tells you particulates in the 4 micron size range, between 4 micron and 6 micron. The second number tells you the number of particles between 6 micron and 14 micron. The last one tells you particles greater than 14 micron. Just for everybody's reference. So in an ISO rating of 17, 15, 12, you've got 700 microns particles greater than 4 micron, 200 greater than 6, and 30 greater than 14 is what that number would, if you go back to the original charts we looked at, that's what it would be describing to you. Okay? Beta. Who's heard filtration referred to as a beta ratio? Okay? Beta. A beta of 2 assumes, it makes an assumption that you have 200,000 upstream particles. It's a ratio. It doesn't have to be 200,000, but it's a ratio. 100,000 particles downstream, which means I stopped 100,000 particles with whatever method of filtration I'm using. So I'm 50% efficient. I get a beta ratio of 2. 2 equals 50%. We could sit there and go down to it, but it's basically it's a ratio. Beta 75 is typically what's called absolute filtration. Well, okay, I'll give you absolute filtration. I had 200,000 particles. I left myself 2,666. I get a beta ratio of 75. It says I'm 98% efficient. Go ahead. ISO and beta is based upon an ISO standard test, which is a multi-pass test. Okay? Which means that they take the fluid within a closed lab and they cycle it so many times through the filter and then count particles. And that's how they come up with the ISO and the beta. Beta is a range of efficiency. ISO is a result of that efficiency. Okay? Anybody here from Texas? Texas, there we go. Arizona? Nobody from Arizona? Okay. Maybe the people from Texas. What they use when they do an ISO test is cactus dust. You're from Texas, you should be familiar with cactuses. How often do you find cactus dust in your hydraulic system? Never. Never. Yeah, there you go. There you go. So the point is, these traditional filter manufacturers following ISO. Oh, by the way, who wrote the ISO standard? The traditional filter manufacturers. So they wrote a standard that would make themselves look good, that they could say they're 99.99% efficient at a beta 1000. Well, geez, you know, I could write a test that makes me a genius, right? So cactus dust is what they use when they do this test. Well, why don't they use what's really out there? What's really hurting my system? Silica, iron, all these different real-world contaminants. Well, they don't want to contaminate their system. They're afraid they won't be able to clean up their system enough for the next test. So why would I use something that can hurt my system to test the efficiency of the filters they're selling me to clean up your system? Does that make sense? Because I'm still trying to get there. Okay? That's what traditional filtration manufacturers do. Traditional filtration, we have a saying in my office, papers for farmers. We don't sell paper filtration. The better filtration that's out there in the traditional market, the microfiber glasses, the Q medias, the Z medias, so on and so forth, they have intrinsic problems. The intrinsic problems is my free-floating piece of iron gets caught in the media. The element did its job. It's a marvelous example of the element doing its job today. This afternoon, my pressure changed. I cycled my system off and on, and that piece of media or iron did that inside my element. 3 days from now, after cycling my system, pressure's up and down, everything else, where did that piece of iron go? Your guess is as good as mine. It's out free floating in my system again, creating nightmares. Okay? That's why they have to do multi-pass tests. This is why it's not a single pass environment. This is why they have to do multi-pass tests. The question I led to earlier, 20 pounds versus 630 pounds, and I was relating it back to dollars earlier. Well, Kat's going to tell you, if you pay our premium for our filtration, we'll get you from 630 pounds down to 20 pounds. Well, why wouldn't Caterpillar say, we'll get you from 630 pounds down to 0 pounds? Any thoughts on that? 630 pounds is bad, 20 pounds is better. I understand that. Smoke and mirrors. So what was the answer? Why wouldn't it tell you 0 pounds? Well, that's true enough, because it would be an absolute lie. But even if they could get you to 20 pounds, or down to, let's say, a pound, half a pound, is it in their best? Exactly. We're going to go back to dollars. Caterpillar has a whole business plan based around that 20 pounds. They know if they upsell you on their filtration, and they maintain that 20 pounds, that in a given year, that excavator, that grader, that whatever it is, because of that 20 pounds, is going to return ROI to them, to Caterpillar, umpteen billions of dollars a year. This is Caterpillar saying, hey, if we can maintain this ISO cleanliness level for you, we'll be able to get you from here to here. But they've already determined that by upselling you on their filtration and maintaining that 20 pounds, you're going to come back to them for cylinders, motors, drives, gearboxes. We're okay with this. As a matter of fact, we're going to get you in the back end because we're going to upgrade your filtration, but we're still going to make our front end money. So who here thinks they believe that they understand what ISO is now? Kind of. ISO cleanliness. What does an ISO cleanliness level, what is that in round terms, that 18, 16, 13 tell me? It gives me a very broad window, you're absolutely right, of what is potentially in my system. What isn't it tell me? What doesn't that tell me?
What those contaminants are.
Exactly. It tells me there's something there. It doesn't tell me what it is. So in reality, what benefit is that to me? I've got a worn bearing. I'm ingressing silica sand because the guy in the shop decided to sandblast something beside my unit. It doesn't tell me where the problem is. It doesn't give me a point of origin or origination. So where does magnetic filtration, how does that change this discussion? Okay, I'll explain it to you. Let's take 20 pounds, for example. Okay, so we're saying we've got 20 pounds on a multi-pass test. At the end of the year, we still produce 20 pounds worth of contamination. The average filter, Jeremy, still here, can catch or hold somewhere between 60 and 120 grams of contamination. A single element, average 12-inch element. That's what it holds. Well, for my American friends, how many grams in a pound? 450. Okay? So if my average element can hold 100 grams of contamination, okay, and I've got to stop 20 pounds. That means I'm 5 elements per pound of contamination. The average cost of an element, somewhere upwards of $100 US dollars. Okay? So if I got to spend 5 times $100, that's $500 per pound, and I got 20 pounds, somebody do the math for me. Anybody? That's $10,000. What did I start off with? Dollars. Okay? When you look at a hydraulic system, and you look at the One-Eye product, and you're looking at $10,000 to take out that contaminant, this is a bargain. Okay? By the time I've tried to take out that 20 pounds, I've already done the damage. I'm already there. There's my system, people. On a drilling rig, this represents $250,000 worth of equipment. Sometimes more, sometimes less. By the time I get to that 20 gallons, try to prevent that 20 gallons, or sorry, 20 pounds, I've made Eaton their money. I've made Bosch Rexroth their money by not investing in a technology that allows me to preempt that 20 pounds. I've given away. tens, thousands, millions of dollars in repair costs.
So where are you putting those in the system? In those specific.
Well, again, this is a generalized description. If you look at a project that Roger and I took on a few years ago, precision drilling, okay? We applied them to the low pressure leg of every pump, including the suctions. Precision wasn't happy with that. They were getting good results. Okay, we put them in all the return filters. We changed out all the suctions to the magnetic Y strainers. We put in scrubbers on the K strains and low pressure legs. Precision says their ROI was really good. They were happy with it. They were doing their ISO cleanliness reports. They came to us and said, what can you do in the pressure leg, in the top drive leg? We actually Roger developed a high pressure Y strainer to go in the leg. Every build that precision drilling does now is standardized on that. The most effective filtration you're going to get within a hydraulic system is traditionally lower flow, higher dwell time aspects. Traditionally, in the suction environment. If you look on the table over there, there's the big tall filter with the flange in the front of it. Roger refers to it, this one over here. This guy here. Okay? It's called an MIT filter. Okay? In just about every hydraulic system that's made now, that can be your primary return filter. Back out of your cooler into the tank, that filter itself is designed to be mounted in the tank top. Okay? In the suctions, Roger and I have great debates about it. He has a preference for one of these guys in the suctions. Roger has a preference for those in the suctions. I tend more towards this.
Just about every package we build for customers like in Canada and Kiera have a Y strainer on them, on the suction.
Right. It makes the installation really simple.
So, what material is your reservoir made of? Typically.
99.9% of the time, it's carbon steel. Rolled carbon, well, absolutely. 99 times out of 100, it's what's called pickled and rolled steel. In your guys' environment, it's worse than anything because you have the temperature changes. In Canada, when it gets cold, it's cold. We don't deal with the great temperature inversions, humidity being caught in here, which cause the tanks to scale and rust, and all that fun kind of stuff. The question about the Y strainers, it's amazing the diverse opinion about suction strainers in the world. Parker Hannafin, which is the old Denison Hydraulics, I used to be really close friends with the guy that was the head of engineering there. And he said to me, Rab, he's from Ohio, Rab, if you put a suction strainer in your tank, I will deny you warranty every time. I said, why? Because it's a rock catcher. If you've got rock catchers in your tank, you've got bigger problems than a failing pump. So we brought the idea of the Y strainer to him. Rab, that's perfect. It's external, it's monitorable, and it doesn't create a differential in the suction. So a company that went from, we will not support suction strainers in your tank, to, wow, this is a great idea. You go to Bosch Rexroth, they put a recommendation of putting a suction strainer in every tank. Well, how can you have a difference between one manufacturer to the next? There's only one reason. Dollars. Okay? Because they know that eventually that suction strainer is going to plug off. And it's in the tank. It's a 2,000 liter reservoir. Who's going to go dive and clean that thing? How often are you going to empty the oil of that tank? You're not going to. You're absolutely not going to. So they know that by recommending a suction strainer, which they can justify in their own minds, they're creating for themselves dollars. Okay? Do not ever live under the misconception that these people are doing things in your best interest. Case drain returns. Well, great. So traditionally, piston pumps, motors, things of that nature have case problems, okay? The case being the so imagine this motor here, it's got a drain line that comes out. Oil that gets past the piston has to drain into the tank at a low pressure, okay? Why? Because if you've got high pressure, the casting will split, or you'll pump out the shaft seal. So traditionally, manufacturers put in their literature that the case drain must be taken directly back to the tank unimpeded, okay? For the most part, yeah. It gets real difficult when you're, dealing in Ben's problem there, where he's got an injector that's 125 feet in the air, and he's got to figure out how to get that case drain back to his tank, 400 and some feet away, Ben, yeah. But traditionally, the greatest part of your wear material comes out the case. Little pieces of piston, bronze out of the wear plates, things like that. They come out of and they go directly back to tank, and the manufacturer doesn't want you to filter it. He doesn't want to have any impedance because that case can only take 15, 20 PSI maximum. In the OEI case, we now put MIT filters, a separate one in the case or in the tank. So we've got our return filter and we've got our case filter. The MIT filter, when sized properly, has close to a zero differential. So it's almost the same as taking it directly to the case unimpeded. So if you can do that and provide that level of filtration, you've now broken the wear cycle. Dollars back in your pocket. If you can break the wear cycle, the money's going somewhere. That money has to be spent somewhere. I prefer to take my wife out to dinner. I don't want to buy a new motor. So it's not going in their pocket, it's staying in yours. It's staying in your customers, and you've created a value proposition for your customers. The value of one-eye filtration versus your traditional filtration. I see Jeremy step back in the room. We're not showing a traditional element, but I'm sure you all do know what it is, a pleated element with your microglass or whatever inside it. Has anybody ever tried to take one apart and see what that contamination is inside that element? Yeah, so in a traditional filtration system, we're saying that a single element can hold up to 100 grams of contamination. Well, now you're sitting there with a set of tweezers trying to pick out 100 grams worth of contamination to figure out where it is. In the one-eye environment, okay, heaven forbid you pull out of your hydraulic system and you've got a magnet like that, but you have the ability now to source your contamination. You can tell if it's a bearing. You know what the parts are in your system, your large components, stuff like that, nickel, metal, chromate, bronze, things like that. And you can now, in a magnet like this, heaven forbid you get one like that too, but you can now determine the health of your system. How? You have the ability to dissect, to determine what those wear materials are. Okay? If every time you do a fluid sample, okay, which is always a good idea, because now you can determine the life of your system, and it comes up and saying that I've got high silica. Well, geez. Source. You can source the problem. How am I getting silica in my system? Perfect example. Source oil. Company I was working with was leaving the barrels in the yard. Weren't securing a bung on them. They kept on coming back and saying, Rob, where am I getting my silica from? I don't believe that I'm pouring sand into my system. We went around to his yard. We evaluated his equipment when it's working. We had done everything right. His hands were not putting the proper bung in the tanks. They were putting a rag in them, putting them out in the yard. He was pouring the silica into his system. He wasn't creating it. It was not ingressing. He was introducing it. It happens. It happens more often than you would think of. Okay? It's silly, it's ridiculous, it happens. How do you break the wear cycle? Okay? Traditional filtration has a difficult time with it. Multi-pass ISO tests are not there to benefit you. They were designed to benefit the filter manufacturer. Okay? Multi-pass tests, if I have to take that piece of wear material and put that through my system 3, 4, 5 times before it's caught, it isn't doing any of you any favors. It's not doing any of your customers any favors. It's costing dollars. Okay? When it gets bad enough, it creates heat. Heat costs energy. Energy costs dollars. It all comes back to one thing, the almighty dollar. My American friends understand that. They're getting a discount coming here to Canada this week, right? 25% off, come on. Right? It's all about the dollars. Again, I'm going to go back to the previous question, or one of the previous questions. How do I get my customers, tell them that this is what I need? They listen when it's dollars. When you explain to them that this is what you're spending, this is what your maintenance costs are, and this is what your potential ROI is, return on investment. It's not about, I don't like you, or my buddy works for this, or I think I'm doing a great job. Don't tell me how to do my job. It's about the dollars. You're going to have to work pretty hard and pretty far to find somebody that doesn't have some CEO, CFO pushing on them to reduce costs. Okay? Roger Simonson, later in our conversation, will tell you about the millions and millions and millions of dollars that he's saving these large mining companies and things like that, which long term turns into billions of dollars of ROI. Okay? You're going to have guys like Dale Constantine telling you that how he's changed his systems for his company, how there's been a return on investment. And that's how he got his company to invest in the technology. Like I said, guys, a $200 Internorman filter is cheap. It's designed to be cheap. That $100 replacement element is designed to give you a false sense of security that by changing your element, you're actually improving the health of your system. Okay? It's harder to sell this for $1,500 than it is for the Eaton salesman to sell his filter for $200. Okay? There is a definite upfront shock value that comes with that. Okay? Traditional thinking versus ROI thinking. This is going to give the customer ROI. How many $100 filters does he have to buy to equal this? Well, you look at your $200 upfront cost. So this is now a $1,300 differential. So 13 filters. Okay? Usually within 2 years, filter changes, he's paid for this. The next 2 years, it's free. I don't pay for, there's no wear components in this.
That's just the difference in cost of the filter, not how much you're cleaning the oil up and it's saving you.
But again, you've got to have conversations at different levels, right? When you're talking at the maintenance manager who's looking at his overall maintenance cost, it's this. When you're talking to the CFO and he's looking at the long-term maintenance cost, it's a different conversation, right? When you're talking to the OEM, the original equipment manufacturer, it's a completely different cost because they're looking at the cost between the $200 and the $1,500, and there's no ROI for the manufacturer. The equipment manufacturer, there's absolutely zero ROI, right? Because all they want to do, they want to push that piece of equipment out the door to you, have it last its warranty period, not my problem after that. It doesn't make sense for them to invest in $1,500 for a Advantage 9000. How do you change that method of thinking? Dale Constantine in the back of the room. Wave, Dale. Okay? The Dave Osmonds of the world, the Ben Noels of the world, they turned around to the original equipment manufacturers and said, we want a reliable piece of equipment. We're not prepared to invest in your company $1 million or $7 million in a piece of equipment unless you're prepared to give us a piece of equipment with this type of technology in it. That's how we've changed the industry here. Okay? It doesn't usually work to start at the original equipment manufacturer level. You get end users to realize it and to go back to the equipment manufacturers and say, we will not accept your equipment unless it has. Okay? And that's the level we've gone to. The NOVs of the world, the Arthurs of the world, the servers of the world, they now know that the customers have an expectation of a certain level of reliability, which is greater than it was of just meeting warranty. And the end users are willing to pay for it. Step Energy knows that they're going to get a piece of equipment, and with that, in that quote is going to be an extra $20,000 for the reliability package, just for the hydraulic or rotating equipment. That's the conversations that are being had now. That's the level of commitment we're getting from the end users, the original equipment manufacturers, even some of the oil companies are starting to push back now. How reliable is your piece of equipment? What guarantee that I have that we're not going to get halfway through this frac job and be stuck? We're not going to be able to complete. How do I know that piece of coiled tubing equipment is not getting stuck in my hole and cost me production and time and a whole bunch of fun stuff? It all comes back to dollars. Any way you cut it, heat, efficiency, wear, time is a function of dollars. Nobody's in this business to lose money. Any other questions before I ramble on anymore?
Not being a hydraulic guy myself, is there a particular place in one of these systems typically that's the most likely to fail because of contamination and therefore shuts you down at an unexpected time?
All three. Your tank is definitely the most liberal source of contamination. But again, that's like asking me what color a duck is or how long is a piece of rope. But traditionally, your tank is the gathering source for your contamination.
Okay, but I'm talking about which thing, if it breaks, like you were just saying, say we're putting together a drilling rig package and
Yes.
the equipment on there. We don't want to have this thing in the middle of the drilling process. Something shuts us down. I've sold a lot of different kinds of equipment. This is new to me here, but I've been very, very successful. We stumbled into a thing a few years ago, talking to some customers. This was on some furnace internal materials and things. They wanted to know what to do during a turnaround as far as repairs. They were trying to prioritize what ought to be fixed. So the question we asked them was, which of those components and pieces of this piece of equipment have you had to go back and do some work on because it failed unexpectedly and shut your plant down?
Okay.
Okay,
Well,
that was a whole different approach to them, and we started using that in other places because you're right, everything goes back to dollars. And if you find the right guys, they're always wanting to evaluate these things, and if you can present a good case, it's very strong. I found that for at least the businesses that I've been in, the very strongest was if I'm working with an operational manager who's responsible for that piece of equipment or that plant making money. The one thing that's the most critical to him is to have an unexpected stop in operation.
Absolutely.
Exactly.
Yeah. And so
Predictive maintenance versus reactive maintenance, I understand exactly where you're going from. Are you working mostly in an industrial environment or in a mobile equipment environment?
in our case, it's industrial.
It's industrial. Okay, then I'm still going to qualify my answer and say that your major source of contamination is still always going to be your tank. Your first component that is expressed or exposed to the tank typically is your pump. So by extension, typically and I think the end users would agree with me, that because your pump is your first point of exposure from the tank, would be your pump. Okay? That typically is your first point of failure. I think a lot of times the ratio of pumps to the rest of the system as a wear would probably be a like 1.2, 1.25 to 1 versus the rest of the components in the system. On a decent, well-maintained system, It sees the majority of the pressure changes and the environments and the heat. But usually the failure point, the result is a failed pump. The root cause is your filtration in your tank.
Places where that's been an issue for them, then work backwards from that.
Exactly.
All of a sudden, you have a very strong case.
Correct. But let's remember, because your tank is your settling point for your whole system, the wear material from there, the wear material from there, the wear material from there, then it gets back to your tank, there's really only one way to break that cycle. And that's via proper filtration, magnetic filtration. Right. All these things eventually filter back to the tank. They eventually all come back to the tank. So your return filtration, that MIT that's on the table there, your Y strainers or your scrubbers they're there to mitigate the tank. So in my system, I've got a magnetic filter in the tank, an MIT. I've got a Y strainer that's protecting the pump. Well, there's a reason why that is all concentrated there, right? Just to protect those components, to keep it out of the tank. If you can keep it out of the tank, you can keep it out of the rest of your system. You've broken the wear cycle. The tank is the heart of the system. It's where you keep the blood. It is the blood life of the system. If that's not designed properly or maintained properly, you might as well give up now.
One other question,
Yes,
along with that, early on you were talking about the breather in there, and that's a big issue.
Absolutely.
With tanks, like you say, you bring in a lot of dirt, you bring in a lot of water down where we work. Has One Eye been doing anything with trying to capture anything there? Because you can go and you can do these demos and drag the element through the dirt, and amazing what you pick up there that folks wouldn't think would actually stick to that. Again, that's another place that you maybe get more contamination coming out. I don't know that I've ever seen anything done there. A lot of times those would be filtered or something, and they're not. They're just...
Well, I wasn't mandated to talk about pneumatics today, but let's talk about pneumatics. Several companies we worked with had large pneumatic systems, injection molding presses, things like that. Dealing with air, yes, we do treat air, or One Eye does treat air. One of the new One Eye products, Roger, you don't have an inline here? The little one. One Eye makes a product that is not this. It's significantly smaller. What's wrong with that being underneath your breather? Right? Typically you have microgel, the pink particles that try to take the moisture out of the air. Does a decent job with moisture, doesn't do so much of a great job with particulate. Put that on top of your tank. Put your breather cap here and put that there. It's replaceable, it's serviceable, it's a one-time cost. That's what it's designed to do. Guys, I'm just about out of time. I've just been informed that I'm over time. I want to thank you very much for your time and your patience. Bernie, I hope I showed half as much passion as you did. I want to thank you and for your time and participation.